3.1 big ideas. First big idea is variables. So we have the explanatory variable and the response variable. The explanatory variable is going to be used to predict. And then the response variable is your outcome. Your response variable responds to the explanatory variable. So when you have a graph of these two variables, the explanatory is your x variable, and the y-axis is your response variable. A scatter plot is just a graph of those two variables. So x, y coordinates, x being your explanatory, response being your y variable. So it could look something like that. When you're describing a scatter plot, you need to make sure you include all of these things. So DUFS is the way to remember it. D is for direction, and that goes with your slope. So this one would be a negative direction because the slope is negative, so you could be positive, you could be negative, or like no slope. So those are your options for directions. The U is for unusual behavior or unusual features. The F is for form. For now, all we're going to be looking for is it linear or nonlinear. And then the S is for strength. How close are those points to forming a line? That'll be our strength. And that strength is measured with the correlation coefficient. So this correlation coefficient R tells us a couple things. It tells us the direction. So R can either be positive or negative depending on the slope. It tells us the form. If we're using R, it's going to be linear. So if we're using the correlation coefficient R, our form is going to be linear. And then it also tells us the strength. With the strength, it goes on a scale from -1 up to 1. So -1 would be perfect line with a negative slope. So this would be strong. And 1 would be the same idea, except the slope is positive. In the middle, like a 0.5 would be moderate. And then negative or positive, just telling you the slope. And then 0 would be weak or none. So if you're really, really strong, be close to 1 or -1. The closer you get to 0, the weaker the correlation gets, whether you're going from -1 to 0 or from 1 down to 0. And then whenever you're describing it, use LY words. Moderately strong, fairly strong, something like that. So using those LY words for when it's in between is good. Other things you should know about correlation is it has no units. So correlation has no units. Switching your axes, so switching your explanatory and response variables, will not change R. Correlation is non-resistant, meaning an outlier is going to affect it. So if there's a point that doesn't fall in the pattern, that's going to make your correlation closer to 0. If there's a point that falls within the pattern, it's going to make your correlation stronger, closer to 1 or -1, depending on if your slope is positive or negative. And then last idea about correlation is correlation and causation. They are two different things. So my example for that is ice cream sales and shark attacks. If you look at this scatter plot, it looks like as ice cream sales goes up, shark attacks go up. So that means that ice cream sales cause shark attacks, right? No, not necessarily. Just because there's a correlation between two variables does not mean one causes the other. So ice cream sales do not cause shark attacks, and correlation does not mean there's a causation. So just because two things are correlated does not mean one causes the other one. Sometimes there's other variables that come into play. Maybe for this one, like temperature. As temperature increases, ice cream sales increase, and so do shark attacks.